Hi, everybody. Thanks for coming. It is an honor to be here. Thank you very much. The title of my talk is Healthcare Operational Dashboard for Chaos Engineering in Google Cloud Platform. Nice to meet you. I am Yuri Niño. I am Cloud Infrastructure Engineer at Google. Also, I am Chaos Engineering Advocate in my country. You can find me in LinkedIn, Twitter, Medium as Yuri Niño. So in the next minutes, I am going to talk about a topic that has caught my attention since some months ago. Like me, probably many of you don't know what is healthcare informatics. So I am going to start with some definitions about this. In this part, I am going to present the challenge that as engineers we are facing in this field. Considering that those challenges include chaos in most cases, I am going to explain how to face them using something that we know very well. I am talking about chaos engineering. Finally, considering that chaos engineering is an equation that includes chaos, observability, and resilience, I am going to focus the last part in how you can observe the chaos on Google Cloud Platform. So the first thing is to clarify the difference between health informatics and healthcare informatics, two concepts that I am going to use in this presentation as a similar thing. Both fields share several characteristics in common since they focus on healthcare technology and data. However, healthcare informatics tends to focus more on the people and processes that manage the technology and data, while health informatics focuses more on the development, maintenance, and use of technology and data. In summary, healthcare informatics is defined as the integration of healthcare science, computer science, information science, and cognitive science to assist in the management of healthcare information. So let me start with some history related to that. So historically, health informatics has been about applying technologies rather than gaining new knowledge. This field has a long history. Since the 1950s, when computers could first store and process large amount of data, software developers have seen healthcare as a fertile domain. Electronic medical record systems date back to the early 1960s when Akron Children's Hospital and IBM created HIS, the first computer-based clinical hospital information system. During the 80s, healthcare informatics experts put their attention on interoperability and data sharing. Starting in the 1990s, this challenge was faced with REST, Health Level 7 or HL7, and Fast Healthcare Interoperability Resources or FHIR, which refer to a set of international standards to transferring clinical and administrative data between software applications used by various healthcare providers. Finally, since the 20s, new capabilities were added using machine learning, artificial intelligence, IoT, and chaos engineering. So let me talk now about our challenge related to healthcare informatics. In 2016, Richard presented the Human Brain Project in a TED Talk. That is a really, really good TED Talk. So while he presented in 2016, Richard presented the Human Brain Project in a TED Talk. While he presented his role in the Human Brain Project, he explained several challenges in healthcare informatics. He mentioned how difficult it is to have complete, structured, standardized, clean, and protected data in the hospitals. Also, he described the persistent problem of integrating several sources of information. That is a problem still challenging. Finally, he referred to another interesting challenge is related to privacy and the digitalization of consents. That is really important for people involved in this field. So Richard and many experts made great advance facing those challenges for what they supported of the available technology. Although I am talking about 2016 and the public cloud was on the table, as you know, the healthcare solutions were deployed on premise. Here is a photo of the big servers used by the human project, the same in which Richard participated. So while the industry of health informatics was growing, the technology made the same but its size. Many industries started to move their workloads, but healthcare is an industry with delay. Right now, they are reacted this revolution, so they are in the phase in which you are moving workloads to the cloud. So that is the current phase for this industry in our ecosystem. So, for example, Accenture published an article during COVID-19 which questioned this attitude and these delays of the healthcare industry. Here is the reference. Here is the reference. So everything work properly when we face one of the most challenging things, an outbreak. So COVID-19 accelerated the cloud adoption. According to Gartner, after COVID-19 crisis, the worldwide end user spending on public cloud services is forecast to grow 18.4% in 2021 to total 304.9 billion. Uh, that numbers were published by Gartner company. Now, healthcare informatics has more challenge. I am talking about classic challenge, still without solution, which include patient identification, quality data integration, privacy and consent researching. Uh, but since the industry decided to move the workloads to the cloud, we have more challenge. I am talking about cloud adoption challenges, security and reliability, operational excellence, performance efficiency, balancing and scalability, observability, and cost optimization. And if you consider, finally, if you consider the COVID-19, we have to include more challenge generated by that. So I am talking about telehealth, virtual assistants, AP management, IoT integrations. Now there are a lot of devices for monitoring your health, for example. So data-driven decision and operational dashboards. That is the main topic for this presentation. So although those are a lot of challenge, that was great because, without problems, life will be so bored. So, however, the equation become more complex. The solutions for those challenges have to coexist with another component, chaos. So probably many of you remember the Terac 25, a controlled radiation therapy machine was produced by Atomic Energy of Canada Limited in 1982. Like many solutions, the Terac 25 had to coexist with chaos. It was involved in at least 6 accidents between 1985 and 1987, in which patients were given massive overdoses of radiation. These accidents show the dangers of software control of safety critical systems, and they have become a standard case study in health informatics, software engineering, and computer ethics. Here is where chaos engineering comes as a proper strategy to learn from this chaos and use this discipline to propose resilient solutions. Because remember, everything fails all time, but we can mitigate those failures, learning and providing resilience. I enjoy remember the definition of chaos engineering, so here one more time. Chaos engineering is the discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. This definition was taken from the main principle of chaos website. So if chaos engineering were an equation, it would the sum of chaos, observability, resilience, and resilience. I had a talk in Gotopia related to this equation. So you are invited to visit the Gotopia site and review this talk related to that, related to these 3 components that is really important when you are talking about chaos engineering: chaos, observability, and resilience. So if you miss the challenge, I put them in one slide. In a summary, our current challenges are related to developing a standard user interface designed features, implementing a method for unambiguous patient identification, providing insights for decision support, enabling automated solutions, and two interesting things that are related to chaos engineering equation that is related to observability, designing proper monitoring dashboards, and providing resilience and reliable clinical environments. So here is proper to remember that we are talking about operations. So it's really important, don't see, our mission is to observe the chaos. So with so many challenges, to learn from chaos require observability and actionable insights. Observability plays a key role, validation of hypotheses, steady state behavior, simulating real world events, optimizing blast radius, and all those stages of our experiment where observability plays a key role. Our systems are always generating data. Key is to identify what can be used for observability and how well-architected systems ensure robust telemetry of this data. So let me finish now with how you can provide proper dashboards with GCP. Because considering that not all decisions are made in hospital, not only doctors and patients need to observe the chaos, it's really important as developers, infrastructure engineers, operations engineering, chaos engineering even, SREs, and all engineering involved in this field or involved in any field, we reach reliability if we have observability. It's really important for us. It's really important for the chaos engineering equation, but it's really important for performing our missions with the systems. So I would like to talk about all possibilities that we have to observe the chaos in these architectures. However, time is short. I am going to share one common architecture to face the interoperability challenge. As you see, we have a lot of entities interacting: healthcare organizations, developers, business stakeholders, direct consumers, third-party consumers applications, microservices with a lot of diversity. So you can see there are many points for failing. So although Healthcare API enable a robust, scalable infrastructure solution to ingest and manage key healthcare data types, including HL7, FHRE, and DCOM, for example, it's really important to consider that these components can fail. So here a visualization of that. Although APG allows to face those challenges, the world is inherently chaotic, and there is not too much we can do about it. Information systems, and particularly distributed systems, and particularly healthcare information systems, are chaotic. They are complex. They are changing. They are unpredictable, and so dependent on perfect synchronization of the components that any unexpected event, no matter how small, can turn into a disaster. Many things can go wrong. Hard things can fail, the network can collapse, the increase in traffic in the operation can happen or could happen. So it is really important to monitor the performance of the proxies. Here, an example of the proper metrics that you can visualize using the features available for APG. I am talking about APIs, so that is a challenge for this field. I am talking about interoperability. I am talking about APG, a solution of Google Cloud Platform that provides strategies for managing the APIs challenge. So in this case, APG offers this menu with the possibility to analyze what is happening with AP monitoring, with timeline, with recent events. You have the possibility to investigate what happened in an incident, for example, and to identify anomaly events. That is really important when you want to learn about the past events. It's really important to identify what are those things that are different in comparison with another components in the behavior of the system. So in this case, in this dashboard, we have the possibility to visualize AP metrics. I am talking about AP proxy, proxy total traffic, proxy error rate, proxy latency percentiles, for example. So when you want to monitor chaos, it's really important to have the possibility to build custom dashboards, because probably there are many tools in the market that providing monitoring, but you don't have the possibility to build your proper dashboard, considering that you are unique. You see the world, you see the event, you see the chaos in a different way to another person. It's really, really important to have the possibility to build a custom dashboard. So also is really important to have the possibility to filter in order to minimize the need to dig raw logs, for example, and to have historical use to quickly understand usage patterns compared against previous months, quarters, and years. So here the dashboard investigate what happened, available in the part for investigating in APG. So it is very useful for writing a postmortem. For example, when you are writing a postmortem, it's really important to know what happened and investigate what happened with your components. What is the root cause of failure? So it's important to have the source of chaos in order to provide several root causes and to be proactive in the future, considering that your learnings about the incident and considering your actionables about this. In some cases, or in many cases, when you are writing a postmortem, it is really important to write actionables since what happened with the infrastructure of your system. So generating alerts it is common in this case. So here it is very important to remember the classical four golden signals. The four golden signals of monitoring are latency, traffic, errors, and saturation. If you can only measure 4 metrics of your user-facing system, focus on these 4. Latency, it is an indicator of the time taken to serve a request and reflects user experience. Latency can point to emerging issues. Example metrics include page load, transaction, query duration, time until first response, and time until complete data duration. Traffic is another gold metric, and it is an indicator of current system demand and is also the basics for calculating infrastructure spend. Traffic is historically used for capacity planning. Examples metrics include write and read operations, traffic and retrievals, HTTP requests per second, and active request connections. The third metric is error, or is related to errors. It is an indicator of the rate of requests that are failing. It is essentially represents the rate of errors and an individual service and for the entire system. Errors represent the rate of requests that fail explicitly or implicitly by policy. Examples metrics include 400 and 500 HTTP codes and number of exceptions, stack traces, dropped connections. Saturation is an indicator of the overall capacity of the service. It essentially represents how full the service is and reflects degrading performance. Saturations can also indicate SLOs, that is very important for SREs, for example. And some metrics include this memory quota, number memory thread pool, cache, this CPU utilization, for example. So related to GKA or related to Kubernetes, a component that is common in the current architectures for healthcare. In general, for any strategy that you use in cloud to deploy your solution, it's really important to have the possibility to view system metrics collected automatically from Google Cloud Services or for any cloud provider service. Enable SRE best practice extensively used by a cloud provider, including SLOs and SLAs, And here I am referred to the classical golden metrics that I mentioned, and collect application metrics from those from workloads or GKA with the managed metrics collection pipeline. And finally, creating these features allows us to create a custom dashboards. So finally, I would like to talk about a great visualization for us. I am talking about heat map. Heat map are common visualization strategy for us, as I mentioned. And Firestore provides a key visualizer, a tool that helps you analyze your Firestore usage patterns in order to identify chaos generated by errors in the communication and performance of the databases. When you map in here, you can use colors and patterns and forms in this dashboard in order to identify or in order to focus on the points that are producing the chaos. It is really important, for example, and it is really useful for troubleshooting performance issues. That is common to use this. So to close, I would like to share this. Healthcare is a complex adaptive system. They are not linear, random, and chaotic. And they are composed of agents whose behavior is dynamic, psychological, and based on social rules. So it's really, really important to use that things we know in this industry, because this industry is growing and it's really important. Healthcare is really important for us. Without help, you don't have anymore. Because if you feel bad, if you feel ill, you cannot work, you cannot perform on your daily activities. So it's really important as engineers uh, providing the proper strategies, provided our knowledge about the past situation in order to build a great systems and reliable system for this industry. So I would like to use another quote: "A health systems require software renewal, and this renewal include chaos engineering. In the middle of the chaos, those systems require new, observable, and reliable software and hardware." So it's really important to have in our minds. So thank you very much for being here. It was an honor to be here. As I mentioned, you can find me in LinkedIn, Medium, and Twitter as Jurinino. Have a great day. Enjoy the another talks. Bye.